multi-step one variable equations using or involving absolute values. Let's read together. 1, 2, 3. I can solve multi-step one variable equation involving absolute values. So at the bottom left of your paper, where you write your objective, make sure you circle or underline with red solve. Circle and underline with green one variable equations. And with blue, I want you to box where it says absolute value. Today we're going to be looking at this different approach to multi-steps. Okay? So once again, just by looking at the objective, we still know that we're on the same concept. Tell your neighbor the concept we're still on, please. That is correct. One variable equations. And we know what they are. I mean, we already have been going at it for chapter 2. One variable equations, we know what they are, what they're not. Let's continue. We know our steps. Tell your neighbor the steps, please. 4 steps. So by now you should know it. Yes, thank you. By now we should know this without even reading it, right? Okay, let's continue. So for this next part, I need pens down, eyes up here. Now I'm going to do a quick intro to absolute values. I know you guys saw this last year, but just to clarify any doubts, here it goes. So I just need your attention. Here it goes. Writing utensils down, eyes up here. Absolute value. The absolute value is the distance of a number away from 0. The distance of a number away from 0. Absolute value is the distance of a number away from 0. Absolute value is the distance of a number away from 0. Absolute value is the distance of a number away from 0. What is it? Okay, so yes, check this out. These are the symbols that we use for absolute value. So whenever you hear the word absolute value, the first thing you think is those 2 parallel bars. Okay? So yes, what is the absolute? The distance of a number away from 0. Okay? Did I make the point? Okay, right now we're thinking it's the distance of a number away from 0. Okay, so let me show you a different way of looking at it. Here it goes. Let's say the question is, what is the distance of negative 25 from 0? Well, there it goes. 1, 2, 3, 4, 5, 6, 7, how many steps? Okay. Or if I was to ask one of you, and I would say, Michael Jordan, can you step outside, please? And then I want you to go heel to toe, go counting steps all the way to the front office. Did they go counting heel to toe like that? Is that person going -1, -2? No, right? We always count in what? Positive numbers. That's why we said 25 steps. We didn't say -25 steps. So the distance of 25 from 0. Another way of saying that is, what is the absolute value of -25? Because what do we know about the absolute value? It's the distance of a number away from 0. So therefore, what's another way of writing this? We know the symbols, don't we? What are the symbols? 2 parallel bars, so therefore there are the parallel bars, and that's -25. So this is the same as saying, what is the absolute value of -25? Or, another way of saying it, what is the distance of -25 away from 0? So how many steps did we say it was? 25, so that's why we get 25. Are we there? Okay, so far so good, right? So we're clear on that. Now look at this one. This next one is a little bit different. Check this out. The question is, what number is 23 steps away from 0? Look at this one. The difference from this one to the previous one, they're asking for the distance, aren't they? And look at this one. They already gave us the distance. There's a distance. What is it that they're asking for? What is the number? See how it's a little bit backwards? So check this out. So if we don't know the number, but we know the distance, don't we? Okay. So let's think about this. Okay. What number? Let me draw a number line so you guys can picture it. I'm going to draw it over here. Right now you're just paying attention. What number is 23 steps away from 0? Just think about it. What number is 23 steps away from 0? Tell your neighbor, please. Okay. I heard 23 and negative 23. That is correct. Both of those numbers are 23 steps away from 0. Okay? So before I move forward, I want you to copy that on your note, but I want you to copy it right underneath that concept map for absolute values that I gave you. There's an empty space between the problems and the concept map. Do you see that? Yes. Copy it in there, please. Okay, let's continue. So, everybody look up to the screen. So check this out. This is what I do when I solve absolute value equations. I do this. I draw 2 arrows because I know that I'm going to get a solution for the negative distance or the negative number, and I'm going to get a solution for the what? For the positive number. So now this is what I write. For the negative one, I write x, bless you, equals, what do I write? Negative 23. For the positive, I write x equals 23. And at the end, the way of saying these are the solutions to this is like this. You write the brackets, which means solution set, negative 23, comma, 23, and we just write solution set. Copy that, please. If it doesn't fit right underneath, copy it on the side. So yes, for the answers, I want you to do this. You box your answer, this one, and you need to show me that those 2 are included in the solution set. Okay? So what does that mean, solution set? What it means that the numbers inside of this set are a solution to this equation. So check this out. Everybody look up to the screen. If I substitute negative 23 in here, what is the absolute value of negative 23? 23. If I substitute positive 23 in here, what is the absolute value of positive 23? 23. Okay? So far, so good? All right. So, skip the word problems, and at the bottom I wrote 1A. You guys see that on your paper? Copy this next problem, please. 1A. Solve the equation absolute value equals 12. See if you can do that one by yourself. You already have the example I gave you. Okay, let's see. So, first things first, I'm going to sketch two arrows because I know that I'm going to write 2 equations. Is that correct? One for the negative and one for the positive. For the negative, what's inside of the absolute value? X. So I write x equals, and what is my first number? Negative 12. What's my second solution? X equals 12. I box my answers, but I write my solution set. What is my solution set? Negative 12, comma, 12. And once again, what does the solution set mean? That if I take those values and substitute them in there, it should work. Let's see. If I substitute negative 12, what is the absolute value of negative 12? 12. What is the absolute value of 12? 12. Okay. Are you with me? All right. on the right-hand side where it says 1b, copy this next one, please. Okay, 1b, it's absolute value, negative 3 equals 23. Okay, let me backtrack a little bit. Let's do this one together, but I want you to see a couple things. Who saw that in the previous one, it didn't have anything outside the absolute value? Notice that this one is different because it has subtracting 3 from the absolute value. So this is what I want you to think. Everybody look up, please. Here we go. From now on, whenever you see the absolute value, think of it, that's why I covered it, think about it like if it's a variable by itself. Do we know how to solve this kind of equation? What do we need to do? Add 3. So let me take this away so you guys can see it, the entire process. So therefore, we need to get rid of that negative 3. So therefore, what is the inverse? Add 3 to each side. We're left with absolute value of x equals 26. Does this look familiar? Okay, finish it off from there, please. So from here, who did this? Arrow, arrow, positive. Oh, my bad. No, this is what? Negative. This is my negative. Did that on purpose to see if you were paying attention. X equals minus 26. And for this side, it's a positive. Therefore, it's x equals 26. I box my answers like so. And I write my solution set, which is negative 26 and 26. Okay? Tell your neighbor, what does the solution set mean? Tell your neighbor, what does it mean? So the solution set, what it means is that if I was to substitute these values into the original, it makes this equation true. If I substitute the solution set into the original equation, it makes the equation true. That's what it means. When we have a solution set, we substitute those values into the equation and makes the equation true. For example, here we go. I'm going to rewrite it over here. Absolute value minus 3 equals 23. So what is my first value? Negative 26. What is the absolute value of negative 26? 26. And it says subtract 3 equals to 23. So what is 26 minus 3? 23. If 23 equals to 23. Yeah, so it's what? It's true. And guess what? It's going to work the same with 26 if we were to rewrite it. Are we there? Okay. Copy this down, please, so that you can see how we check it and that ends up being true. All right, here we go. Let's continue. No. Copy this next one down, please. Okay, copy this one on the back, please. 1C. Copy that one in the back. Okay, here we go. I'm going to go ahead and walk you through this one first. I'm going to do this first by myself, so pens down, eyes up here. Pay attention, please. Here we go. So, this is a little bit different from what we've been looking at, right? Who notices that now they have an x and a number next to it inside of the absolute value? Okay, so now when we get to these, still, do you notice that there's nothing outside of the absolute value to subtract or add? Is that correct? So we already left the absolute value by itself. So from this point, I do this. I sketch my two arrows, one of them for the negative. And what's my negative number? Negative 8. And I write whatever is inside of the absolute value. What is inside of the absolute value? X minus 2.5. And whatever I do for the negative, I do for the positive. The positive is 8. And then I'm going to write x minus 2.5. Now check this out. At this point, I'm going to work this one. To solve for x, I just use inverse operation. What is happening? It's subtracting 2.5. So what is the inverse? Add 2.5. Whatever I do to one side, I do to the other, 2.5. In order to add these two, I add a decimal and a 0. What is this? This is 0. I'm left with x equals, let's see, negative 8 plus 2.5 is negative 5.5. Now, let me work this one out. Add 2.5, bless you, add 2.5. I add a decimal and a 0. These cancel. We're left with x equals, what is 8 plus 2.5? 10.5. So, my solutions are these two. And my solution set is negative 5.5, comma, 10.5. Don't copy yet. Let me explain why we got two different numbers. Check this out. Once again, who noticed that inside the absolute value, they're subtracting something to the number inside? That's why these do not match. If there was an x only inside by itself, these match. Did you see the previous problems? On the previous problem, since we had just an x, that's why this is exactly the opposite of this one. Look at the previous one. Since we had an x only, that's why this is the opposite of this one. Since this one had an x only, that's why this one's the opposite of this one. However, this is different because it has a what? They're subtracting something to that number. Are you with me? Kind of like if I gave you a mental math. Don't look up to the screen, but think about it. If I was to say, think about a number, take away 2, and then, you know what I'm saying? And then you start building up from there. So we're no longer with the original number. Now you have a different number, don't you? Okay, that's what's happening here. That's why we end up with two different numbers. Copy that, please. All right, copy this next one down, please. Okay, this next one, label it example super cube. Here we go. Absolute value, x plus 7, close the absolute value, equal to 30. This is all exactly about the same as the previous example. See if you can do that one by yourself. Go. Okay. First, I want to know who did this. You arrow, 1 negative. So therefore you wrote negative 30 equals x plus 7. And 1 positive. So therefore you wrote x plus 7 equals 30. Hands if you did that. Okay. Next, let's solve each equation using inverse operations. I'm going to start with this one first. Minus 7, x equals negative 37. That's one answer. For this one, minus 7, x equals Michael Jordan. Okay. And therefore, my solution set is negative 37, 23. Once again, tell your neighbor what the solution set means. Okay, so hands if you got that by yourself. Okay, not bad. Okay, let's continue. Copy this one down. Example 1D. 3 times absolute value x plus 7 equals 24. Let's do this one together. This is going pretty fast. What's right outside the absolute value? What is it doing? Multiply. We don't distribute because this is not a parenthesis. It's a grouping symbol, but it's not a parenthesis. It's a 3 and it's multiplying. What is the inverse of multiplication? Divide by 3 this side and divide by 3 this side. We're left with absolute value x plus 7 equals 8. From there, we know to draw our two arrows, one for the negative, and that is going to be -8 equals to x plus 7, and one of them for the positive, and that is x plus 7 equals 8. And we solve, don't we? -7 minus 7, x equals -15. -7 minus 7, x equals 1. So my solution set is -15 and 1. Okay, copy this next one down, please. Okay, copy this one, please. It says -8 equals absolute value x plus 2, close the absolute value, minus 8. Let's do this one together also. You're going to see how this is a little bit different. Here it goes. What is the inverse of subtracting 8? Isn't it subtracting 8? Yes, the inverse is to add 8 to each side. We're left with 0 equals absolute value x plus 2. So, isn't this weird that we have a 0? Let's see. Could we get a -0 and a positive 0? No. There's no such thing, right? So I just write one equation. 0 equals x plus 2. And let's solve it. Subtract 2, x equals -2. Who noticed that we have a one solution absolute value? And who noticed that all the other ones were two solutions? So check this out. One thing to remember, whenever you end up with a 0, there's only going to be one solution. Whenever you end up with a 0, you only have one solution. And the last one, just pay attention to this. Check this out. To solve this one, I subtract 3. Absolute value x plus 4 equals -3. Since I have a negative, there's no solution because there's no such thing as a negative absolute value. Everybody got it? That one's no solution. So homework found on pages 117 through 118, 1 through 35 odd. Turn in your homework on your way out. Enjoy your homework. Have a good one. See you guys tomorrow.